Until the beginning of the previous century, astronomers theorized that our galaxy, with the billions of stars it holds, was the only galaxy of the universe. Basically, they believed our galaxy was the universe. And then, at the beginning of 1920, Edwin Powell Hubble made an observation that would change everything. Hubble had one of the most developed telescopes of this era. So, with extremely detailed observations, he managed to calculate the distance of space objects that were broadly known as nebulas. One of them was known as the Andromeda Nebula. By studying stars that were on this object, Hubble realized that it was too far away to be a part of the Milky Way galaxy. After many other observations like this one, he came to the conclusion that the universe consists of numerous galaxies that contain billions of stars. Therefore, the Andromeda Nebula was renamed to Andromeda Galaxy. Andromeda's galaxy is the closest galaxy, and lies at a distance of 2.5 million light-years. This means that light needs 2.5 million years to reach Andromeda. With speed of lighting reaching approximately 9.46 trillion km per year, this is just too far. And the mind-blowing fact is that you can actually see Andromeda with naked eyes. More of how to do that in another video. Back to our topic. Hubble used an effect known as the Doppler effect. According to Doppler effect, when a light source is moving away from us, the light source's color is shifted to the red end of the spectrum, and when it approaches us the light source's color is shifted to the blue end of the spectrum. Thoroughly observing faraway galaxies, Hubble realized that their color was shifted to the red end of the spectrum. Therefore, he came to the conclusion that all of the distant galaxies are moving away from us at high speed. Also, he made a very important observation that is known as Hubble's law. The more distant a galaxy is, the faster it is moving away from us. Therefore, Hubble came to the conclusion that the universe is expanding. It is easy for someone to be tempted and theorize that if everything is moving away from them, then they must be at the center of the universe. But in reality, wherever we were in the universe, we would see distant galaxies receding. Why is this happening? It might be easier to understand it by thinking of the surface of an expanding balloon. If you are on the surface of the balloon, while it's expanding, you will have the impression that all the other points are moving away from where you are. With the exception of a small number of galaxies that are gravitationally bound to our galaxy, all other galaxies are moving away from us. And like we said before, the farther they are from us, the fastest they recede. But why is this happening? Why does distance affect velocity? The explanation is that the space between the galaxies is expanding. Therefore, the more space between the two galaxies, the fastest they move away from each other. This can be illustrated by an example. The distances between the galaxies are the ones we see in the picture, where each circle is a galaxy. After a period of time, if the space between the galaxies increases uniformly, the distance between them will also increase uniformly. Now, let's see how an observer would see that shift from point X. From the observer's perspective, it looks like all the galaxies have moved away, and the farther ones even farther away. Of course, it doesn't matter which galaxy we pick as the observer. Any point that we use as our reference point will see the farthest galaxies moving away from the point at a greater speed than the rest. Newest discoveries show us that the expansion of the universe is not occurring at a stable rate, but an accelerating one. The bigger the balloon gets, the fastest it expands. That led the cosmologists to the idea of dark energy, an exotic form of energy that forces the universe to expand at an accelerated rate. Now, knowing that the universe expands, what would we see if we went back in time? Instead of seeing galaxies moving away from one another, they would get closer and closer, until eventually, all the matter of the universe would be in one particular point. This particular point is called singularity. The temperature in this point is extreme, and the density is infinite. The whole universe emerged from this particular point. Therefore, that theory was named Big Bang, meaning big explosion. However, it's more of a very rapid expansion than it is an explosion. An expansion that started 13.8 billion years ago. This number is also the age of the universe. The Big Bang theory has also predicted, with relative accuracy, the morphology of the great structures of the universe, such as galaxies. Also, the age of the oldest stars doesn't contradict the age of the universe according to the theory. As always in science, the theory can be improved or enriched and some of its aspects may even change, but to this day it is the most complete theory on the explanation of the evolution of the universe. As a finishing note, the closest galaxy to ours, the Andromeda Galaxy, is gravitationally bound to ours, meaning that they move closer to each other. 4 billion years from now those two galaxies will collide and unite. If life exists at that time in the galaxy, the spectacle they will see in the night sky will be most impressive. This was the Big Bang Theory. I hope you got an idea about what it is, and I'll be glad to read your comments and questions. If you liked the video, you may subscribe to see more like this one. And of course we'll meet again in our next journey.